Hello everyone and welcome to my second devlog. As you might remember from my first video, a part of the basic movement and networking, I have created a tool that allows me to import a real height map from any place of the world and render it as a Unity terrain for my game. With the terrain geometry imported into Unity and the skill of painting it based on height, it was time to tackle one of my favorite topics, water. In order to achieve that, the first thing that I needed to decide it was how to place the water mesh. My first approach was to just set up a point that I could just drag on the map and then just have a magic button that would compute the water nodes, and you would see it just going down until the edge of the map, and this was the first thing that I tried. So with the first approach in mind, what I thought it was just that I could take one point and then just make the water go down until the edge of the map, and this is the first thing I implemented. As I thought that this was going to be easy, I just used my terrain script that allowed me to texture a point of the terrain based on its position to see the result happening, and this was what happened. The water was indeed going down, but it stopped at the first local minimum because I was forgetting the big picture. This was happening, of course, because the terrain doesn't have this shape really. The terrain has more this shape, something with local minimums and local maximums. So the next thing that I had to solve is how my water would do something like this: go to the local minimum and then, without going back, continue finding all the path until the edge of the map by finding which would be the points that it would choose, even if it had to go up. So with this problem in mind, I woke up early the next day and fired up Visual Studio and started coding a solution. But it wasn't as easy as it thought it would be. After a little bit of coding, this is the best that I managed to achieve. The water, for some reason, was stopping in a random point in the map, forming some sort of a lake. This was happening because we are not in a 2D problem, we are actually in a 3D problem. So probably the water was doing something like this, choosing this, then going down to this, going down to this, this, maybe here, maybe there, and suddenly it was just stuck. So what I needed to do is to add some sort of memory to test other paths to try to go out of the loop, and this is what I did. Even though this may look like the end of the problem, I knew that there were still a lot of questions unanswered. What are my rivers? Where are my lakes? How do I fill them? Where do I place the meshes? What direction are the rivers following? All these questions made me realize that just playing with heights, even if it was a good start, this wasn't the end of the problem. I needed a more powerful approach. I thought about it for some days, and after reading some articles about fluid simulation, I realized that the problem was harder than I thought and computationally expensive. So I came out with this solution. My idea was to see the terrain as a graph, and then each node could store things like the amount of water that it has, the in nodes, the out nodes, its height, inertias, maybe if it's a maximum or a minimum, or which is the closest local maximums that it has, the closest local minimums that it has. Like this, I could just apply classical techniques like BFS, DFS, Dijkstra, and things that were familiar to me. With the graph computed having all the information that I needed, it wasn't that hard to find the right water path, and I did it by using an aggregation of the following techniques. Seeing my problem in 2D again, what I did is, first, choose a point as my starting point. Then use the fact that a given node knows which of its neighbors has a positive slope or a negative slope, and then just follow the negative slopes, trying to preserve the water direction. Meaning that if, for example, I go here and then I have two possible directions with the same slope, what I would do is to preserve this one, or to go to this direction, because I'm being pushed this way. Like this, I get some sort of a more natural water reaction. Once I do that, when I reach a local minimum, what I would need to do is to just use BFS in order to find the next local maximum that hasn't been visited yet. So now that I have my main water path, the only thing that I need to do is to figure out which of these nodes are rivers and which of these nodes are lakes. So what I did is to try to, from these local minimums, try to fill somehow everything with water. This means just that I need to find all the nodes that are below this surface. Just by using BFS, I can just query and just see all the connected nodes that are below this surface. So like this, I can find lake 1, do the same thing here. So I would find lake 2, just by finding all these nodes. Then do the same thing for lake 3. And then, as this is absurd because these are lakes inside lakes, the only thing that I need to do is to check the intersections between these planes and just remove these lakes, keeping just lake 3, so my lake, and all the nodes that are not part of a lake are my rivers. And that's it. From here, I opened the beer and started thinking about my next challenge. My problem was that I had some points on the 3D space, like the rivers and then the lake and then again the rivers, and I needed to find a way to convert these points into something that looked like this, like surfaces where I could just create a shader and have all the fancy stuff like reflections and refraction, scrolling textures, in order to get some sort of rivers and lakes. After some research, I figured out that I needed something called a triangulation algorithm, and math came into rescue with this algorithm called Delaunay or something like this, where I could just have a set of points and find the minimum representation or the minimum triangles that will connect all these points. And this is what I implemented next. As you may see, my first try was a complete disaster, but I didn't surrender. Another silly issue that I had was that my river were only a rect of points, and you cannot create triangles for just one point each. What I had to do is to go to my graph again and try to, for example, for this river, get some more points, some more neighbors, in order to have a point cloud to apply the triangulation algorithm. After a lot of silly mistakes and Unity crashes, finally I got a solution that was good enough for my use case. From here, it was time to do my favorite part of computer graphics, shaders. So, in order to create a water shader with real-time reflections and refractions, the first thing that you need to do is to take the player camera, duplicate it, and move it below the surface at the same distance than the original one. Then, be aware of this near clipping plane, because it allows you to skip any object that is between him and the camera. What you need to do next is to move this plane to the water surface, like this. And you can do that by just computing the oblique matrix that will generate something like this. You will have a matrix that will skip anything that is below the surface. Like this, you won't see any fish swimming on your reflection texture, because what you really want to render is anything that is on top of the water, like mountains and clouds and anything. Then just you need to take a picture from this camera and project it into the plane by doing something called perspective division. If you do it like me, so incorrectly, what you will get first is something like this, meaning that my coordinates, my projected coordinates are not correct. You can see that I'm doing something wrong, but after a little bit of coding, I managed to get it right and get some sort of a mirror. So in order to get the refraction texture, the only thing that you need to do is the same, but from the player perspective, meaning that you need to take this near plane, compute the oblique matrix, and take a picture of anything that is below the surface, like a fish or something. But now you will have two textures and only one plane to texture, so how do we mix them? In order to do that, there's something called the Fresnel Equations that model exactly that. Essentially what they will do is to, when the camera will be really close to the surface, like here, you will have only this like mountains or anything that is above the surface. But if the camera is more perpendicular to the surface, what you will get is only what is on the bottom of the surface, which is what happens in real life. So here, as you can see, now we can see the reflection texture rendering the mountains, but as soon as I go more like this, I will only get the bottom part of the lake. And if I'm for example here, I will have a combination of both. Then what we want to achieve is to have like something called foam close to the shore, which is these white spots that the water has in these positions. In order to achieve that, the only thing that you need to do is to take the depth texture of the water, or of the terrain really, and then the eye depth from the camera to the water surface. And all the points where these 2 points are too close, so maybe this triangle here, everything that is on this sweet spot will be rendered in white. You can see the effect here. So you see that all the points that are close to the shore are rendered in white. Now, even if the result is quite good, usually water is not that clean. You don't see the refraction texture that good. We need something called distortion texture, which is something like this, which has colors on the red and the green channel. This texture will tell the shader how many pixels to the left, for example, with the green channel, and to the top or bottom with the red channel, you will need to move your image in order to get some sort of distortion. After applying this depth map on the shader, you will be able to have something like this. As you see now, the textures are distorted, giving a way better result. After doing the water shader, the river shader was really easy to do, because what I did just is to apply the same foam technique and just some scrolling textures to give the impression that the water is moving, add some particles on the joints with the lake, and yeah, I think that that's the end of my water generation journey. It took longer than I expected. It took something like 1 month when I was expecting 2 weeks. But yeah, I'm not good at estimating time. But it's here, it's working even in the Unity editor. You have the rivers, you have the lake, and everything is working properly, even if I wanted to surrender at some point because things were getting just crazy. And here you can see it even from the player perspective. And to be honest, even if it's programmer art, it doesn't look that bad. And yeah, probably now it's time to move to gameplay again, which has been a little bit forgotten these days. And I will continue with crafting mechanics. Probably you will be able to craft something like a campfire on the next video. And yeah, the idea is to create a mini game, as I did the last time, where someone can join the server, and for example the first one that is able to craft a campfire will win. Like this, I like to keep like creating mini games from the actual game mechanics that I have so far. Like this, it's funnier to develop, as the project is quite long. Yeah, it makes things more funny. So yeah, thank you for watching. I hope you enjoyed the video and see you next time. Bye.